Hi everybody, today we are doing degrees and radians. So you're probably pretty comfortable with degrees at this point, 360 in a circle, and radians might feel a little clunky to you. We are gonna work on that today. So you have the conversions here, right? These are like the official math conversions, but it's interesting, it's easier for me to think about it on the coordinate plane, right? So if we think about our degrees, right, of degrees. If I go in a full circle, that's going to give me 360 degrees. That is the same as 2 pi. So what that means is that halfway around the circle, right, 180 degrees, that's the same as pi radians, right? Pi radians. So 180 and pi are equivalent to each other. This one is measured in degrees. This one's measured in radians. So if halfway around the circle is 1 pi, then all the way around the circle, another 180 degrees would be another pi, right? So all the way around 2 pi. We can break it down from there. So let's say instead of going 180 degrees, I only go halfway, right? That would be 90 degrees, right? That 90 degrees is a half a pi. It's pi divided by 2, just like that, right? Let's say we didn't go halfway, call this pi over 2. Let's say we went halfway to halfway, right? We went to this space here, right? We would probably know that as 45 degrees, but we could also say that that's pi over 4, right? It's pi over 4 because it would take us a fourth of pi, a fourth of pi, a fourth of pi, and a fourth of pi to get all the way to 4, right? We have 1/4 of pi. So 45 degrees is a fourth of pi. So what we would say here, the first two, that'd be good to memorize. Pi over 2 is going to be 90 degrees, and pi over 4 is going to be 45 degrees. Even if you don't write this part in your notes, this part, this box here should definitely be in your notes. All right, so pi over 2, that's 90 degrees, and pi over 4 is 45. If we want to break them up in a different way, right? So let's say we want to break them up in a slightly different way. We could talk about thirds, right? So if I split this into thirds like this, I have 1/3, 2/3, 3/3, right? 180, you can imagine. Be like, oh, if I split that into thirds, each of these is 60. So 60 degrees is pi divided by 3, right? So pi over 3 would be 60 degrees. Then we could have 120, that's 2/3 of pi, and 180, that's 3/3 of pi, right? So if I was writing 120 degrees, I'd have 2/3 pi, or 2 pi over 3. 2/3 pi, that's 120. Let's say I wanted to get even smaller, right? I want to get even smaller. I don't want to deal with 60, but I want to deal with 30 degrees, right? I'm taking that 1/3 pi and splitting it into 2 parts. That would be pi over 6. Pi over 6. Pi over 6 is the same as 30 degrees. Right? So these are the big four. These are the ones that it is helpful for us to memorize, although you can definitely figure out what they are based off of. You can definitely figure out what they are based off your knowledge of half a circle is 1 pi. Okay. So if I'm thinking about it like this, I'm going to use these in order to figure out where these angles are. So let's start with reading the directions. Draw the given angle in the appropriate quadrant. So we want to draw it. Label in radians and degrees. So we already have it in radians. We're going to label it in degrees as well. And then we're going to label what's called the reference angle in radians and degrees. So the first thing that I'm going to start with when I have 3 pi over 4 is I'm going to identify the pi over 4. Remember, pi over 4 is 45 degrees. I have 3 of them. So this is like 3 times 45 degrees. 3 times 45 is 135 degrees. Or if you're thinking about it on our graph here, we have 3/4 of a pi, right? So if pi is 180 and we split it into quarters, 1, 2, 3, that would mean that our angle would be over here, right? This angle here would be 3 pi over 4. And it would also be 135 degrees, right? That's that angle there. Our reference angle, right? Our reference angle is the angle inside, right? So if you're thinking about this triangle that we would be drawing here, this right here is referred to as the reference angle, right? We draw it like this. We put like a theta. This is how the computer makes it. This is how I do it on paper. And then I put a little r down here like that, like a subscript, kind of like an exponent, but on the bottom. So I have theta, my reference angle. It's how much I have to get to the bottom. It's easy for me to think, oh, well, I have to go 1 more quarter pi to get to a whole pi. So pi over 4. Right? And I know pi over 4 is 45 degrees. Same thing if I wanted to get from 135 to 180, I would need to go 45 more degrees. So my reference angle is 45 degrees, or pi over 4 radians. All right, let's double check. Did we draw the given angle? Yes, we did. Did we label it in radians and degrees? Yes, we did. Did we label the reference angle in radians and in degrees? We did. So we have done all the steps for this problem. Okay. So here I'm going to do a few more examples. We have 5 pi over 3. So I'm thinking pi over 3 I know is 180 divided by 3 would be 60, right? So this is really 60 times 5. Okay, so that is a lot of degrees, 300 degrees. So I'm thinking, okay, we're going to start here. We're going to go all the way around 270 and then 30 more. So I'm going to have this line here, right? This one here, this angle all the way around, I use here, all the way around is 5 pi over 3. It is also 300 degrees. Notice I label it on this side, on the outside here, since we are going all the way around. And then the reference angle, remember, if I was going to make this triangle, reference angle is straight to the x-axis. So straight to the x-axis, this would be my reference angle. If you think about like how much further I would need to go to get to 360, it would be 60 degrees, which I know that's 180 divided by 3. So I'd have pi over 3. Right, so I have my reference angle here, and I have my angle drawn in the correct quadrant with the degrees and the radians. Right, so here we're just getting a viewpoint for the relationship between radians and degrees. Let's go ahead and take a look at this one. This one says 3 pi over 4, it is negative. So when we go in a positive direction, we move in a counterclockwise direction. We start at 0 and we move counterclockwise. When it says negative, we're going to move the opposite direction, or we're moving this direction. So negative 3/4 pi, right? So I'm thinking pi over 4, I know that's 45 degrees, and there's 3 of them. So that's going to be 3 times 45 degrees would be 135, and it is negative, right? Negative degrees. So I'm going to be headed this direction, 3/4, like this. That's going to give me a negative 135 degrees, also negative 3 pi over 4, right? That's my original angle. My reference angle, remember, is straight up to the x-axis. So my reference angle needs another 45 degrees in order to reach there. And I know that that is 1/4. So that is going to be pi over 4, like so. Pi over 4. Cool. Great job. All right, go ahead and pause your video and try this one on your own. And we'll come back and explain it in a moment. All right, so pi over 6 will be 30 degrees. We have 7 of them, 7 pi over 6. So that'd be 210. That's going to be this entire angle getting to here. I know my reference angle is from the line to the x-axis. That is my reference angle. So my reference angle, I know that this is 180, and then we went 30 more. So my reference angle is 30 degrees. I know that that is pi over 6. Pi over 6. So, oops, I should label. Do make sure that you label your original angle, 210, and this is 7 pi over All right. So now we're going to do some straight translation, like conversion from degrees to radians or from radians to degrees. It's going to look a little like stoichiometry, I believe is what it's called in chemistry, where we're actually just converting something from one format to another format, from one unit to a different unit. So for the first four, they're going to tell us in degrees, and then they'll tell us in radians, and we're going to switch them into the opposite. So for degrees, what we're going to do is we're going to multiply times a fraction. If degrees is on top here, we're going to have degrees on bottom here. So 180 degrees is equal to pi radians, right? So what we're doing here is we're just thinking about multiplying by 1 over 1, basically, right? These are equal to each other. So we are putting it in a different format. That is going to allow the degrees to cancel out and leave us with just radians as our unit, right? Just radians as our unit. So I'm going to go ahead and I multiply straight across. Remember, this would be like over 1. So I'd have 300 pi over 180. I can simplify. I know these are going to cancel there. 30 over 18 could become, I could take out 2, but I could also take out 3. Since I can take out 2 and 3, I know I could take out 6. So I'm going to go ahead and divide by 6 on top and bottom. So I get 5 pi over 3. So 5 pi over 3 is the same as 300 degrees. I'm going to go ahead and write my units here, which would be radians. They can abbreviate to RAD. Okay. So I'm going to do the same thing for a problem like 45 degrees. So multiplying times pi over 180. So I get 45 pi over 180. Those are both divisible by 5. They are both divisible by 3. So they're both going to be divisible by 15. So you can take two steps at this if you want. So like dividing by 5, I'd get 9 pi over 180 divided by 5 using my calculator is 36. And then I see like, oh, they're still divisible by 3 each. So 3 pi over 12. They're still divisible by 3. So pi over 4. Pi over 4. I mean, alternatively, if you have them memorized, you could go from 45 straight. You could just say like, oh, that's pi over 4, right? But it is possible to use your powers of deduction or like powers of simplification in order to get to pi over 4 radians, right? But memorizing will be super helpful. So go ahead and try negative 30 and negative 150. Doesn't change anything about it with the negative. Your answer will just be negative. Go ahead and try those on your own. Be back in a moment. So for this first one, I multiplied times the same conversion, got negative 30 over 180, divided by 30 on top and on bottom, negative pi over 6. But same thing, right? If you have negative 30, you should be able to go straight to negative pi over 6. For negative 150, same thing, exact same process. 150 is this, negative 5 pi over 6. Something to notice between them, 30 is 5 times, or 30 times 5 would be 150. So it makes sense that pi over 6 times 5 would be negative 5 pi over 6, right? So notice the relationship between degrees. If I'm multiplying with degrees, I'm also multiplying with radians. So you can see that same thing, okay? When we are given radians, for example, pi over 12, we are going to flip that conversion because we want the pi's to cancel. So now the radians will be on the bottom, the pi will be on the bottom, and 180 degrees will be on the top. So what happens here is that I would have pi times 180 would be 180 pi, 180 or 12 times pi would be 12 times pi. Pi over pi is 1, that's going to cancel. And I can do some quick math here. 180 divided by 12 is a whole number, 15. This is 15 degrees, right? 15 degrees here. So pi over 12 would be 15. If you think about it this in a different way, if pi is 180, 180 degrees, you know those things are the same, divide them by 12 into 12 sections, you would get 15 degrees per section. So you can think about it in two separate ways there. For F, this one's 5 pi, right? So if you think about that, I'm going around 2 pi, then around again, 2 more pi, and then 1 more pi. So if you think about it on a graph, I have like 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. So I've really gone like around and around. I've gone from here around and all the way around. So done like a big loop here. So I'm thinking, okay, I want pi on the bottom so that it will cancel. Give me 180, cancel 1 pi and pi. We get 180 times 5. 180 times 5 is 900 degrees. So if you're like a skateboarder, that's when you turn around 2.5 times, right? So a 360, then another 360, and then another half turn there. 900. Okay, go ahead and try G and H on your own and come back to me when you're done. All right, so for G, we multiply times 180 over pi. Pi's cancel out right away. 5 times 180 is 540, and then 4 is coming over. That's going to be negative 135. Alternatively, if you know pi over 4 is 45 degrees, then you're just multiplying times that negative 3. And you get negative 135, like we've been practicing earlier today. So you can do it either way. Both will work for you, whichever you like better. The same is true for this one. If I have pi over 2, I can cancel the pi's right away. 180 divided by 2 is negative 90, right? Otherwise, you can just know, okay, pi over 2 is 90, and I'm bringing that negative straight down. So negative 90 degrees. Both ways will help you out here, okay? So for today, we are graphing, right? We're graphing the angle and finding the reference angle. We're practicing the translation from radians to degrees. And then in example 2, we saw how to translate directly from degrees to radians without using the graph, although the graph can still be helpful. Okay. Please let me know if you have any questions. I am happy to support. Thanks, y'all.